Hello and welcome to the fifth topic of quadratics, which is the discriminant. And in here we're going to look at the quadratic formula where b squared minus 4ac is called the discriminant, or in other words, this part here of the quadratic equation, which is b squared minus 4ac, is in other words equal to delta. So how does b squared minus 4ac work? Well, if we have the coefficients 7, minus 8 and 1 for a and b and c, we plug those numbers into b squared minus 4ac, so we get minus 8 squared minus 4 times 1 times 7, which is 64 minus 28, which will be equal to 36. Now, by working out this number, we can determine whether the graph has two roots, one equal root, or no real roots. Now, what does that mean? Now, in here, there's graphs that are represented on the x-axis and y-axis, and so we can see that if b squared minus 4ac is greater than 0, then we have two roots here, and so for the negative graph as well. We have one repeated root. That means when b squared minus 4ac is equal to 0, then there is only one point touching, so there is one equal root repeated, and so here we have no real roots when b squared minus 4ac is smaller than 0, because there is no point at where the graph is touching. So when we get 36, that means that it is greater than 0, and when b squared minus 4ac is greater than 0, then that means we have two distinct real roots. If our value of b squared minus 4ac would be equal to 0, then that means that we have equal roots, and if b squared minus 4ac is smaller than 0, then we have no real roots. So here we got an example question to find the value of k, or values of k, for which f of x equal to x squared plus kx plus 9 has equal roots. Now, when we do b squared minus 4ac, the value here tells us whether the value has equal roots, whether it has distinct roots or no real roots. Now, what happens here is that b squared minus 4ac is gonna be equal to 0 because we have equal roots, which means that there is one repeated root. Now, this means that we're going to plug in the b and a and c of this f of x to work out the values of k. So it is simple as this. We plug in the a equals 1, b equals k, and c equals 9 into b squared minus 4ac equals to 0, because it is 0 because it has equal roots. So the value of b squared minus 4ac will be equal to 0. And we plug it in like this, and we solve it. And we get k equals to plus or minus 6, which are the two values of k. Now the following example is going to make us find the range of values of k for which x squared plus 4x plus k is equal to 0 has two distinct real solutions. So if we have two distinct real solutions, that means that our b squared minus 4ac will be larger than 0. Using this rule over here, And that means that we just plug in the numbers like so. So a equals 1, b equals 4, and c equals k. So that means that 4 squared minus 4 times 1 times k is greater than 0. And now 16 minus 4k is greater than 0. We plus 4k on both sides to get this following. 16 is greater than 4k, and so 4 is greater than k. Therefore, our answer is k is smaller than 4. Now let's go to the exercise questions for 2G, and the following question asks us to find the discriminant for the 2x minus 3x squared minus 4. So we write out our coefficients. So that means that we're going to use b squared minus 4ac to work out the discriminant, because the question asks us to find the discriminant. And we have 2 squared minus 4 times minus 3 times minus 4. So 4 minus 48 is going to be minus 44, which is the value of our discriminant. Now we have a question, given that the function of f has equal roots, find the value of positive constant s. So here we have s x squared plus 8x plus s has equal roots. This means that the following coefficients are a equals s, b equals 8, and c equals s. And we know that b squared minus 4ac has equal roots, so that means it has a repeated root, and therefore the delta is 0. So 8 squared minus 4ac is equal to 0. So 64 minus 4s squared is equal to 0. We divide both sides by 4 to get 16 equals s squared, and we get s equals to plus minus 4, but because we have to find the positive constant s, therefore s equals to 4. So here we got the function of g, and we have said that p is an integer, and the g has also 2 equal roots. So if it has 2 equal roots, that means that b squared minus 4ac is equal to 0. Now to find the value of p, we have to just insert the coefficients of the function of g into b squared minus 4ac. So the coefficients are as follows. Now we can put them in the delta minus 4 times 1 times 14p minus 3 is equal to 0. That means that 9p squared minus 14p minus 3 equals to 0. Now we work out the thing in a bracket, so that is 9p squared minus 56p plus 12 equals to 0, and we solve this as quadratic equation. So that will be a equals to 9, b equals to minus 56, and c equals to 12. I'll use a quadratic formula for this, so x equals to minus b, which is minus 56, plus minus b squared minus 4ac, which is minus 56 squared minus 4ac over 2a. And the following answers are x equals 6 and x equals 2/9. Now I have made a mistake because this should not be x, this should be the value of p that we are working out. So it says in the question that p is an integer. Therefore, 2 over 9 cannot be the case, and p equals 6 is the answer for A. Now for B, for this value of p, solve the equation x squared plus px plus 14p minus 3. So we just have p equals to 6 for this equation, so x squared plus 18x, and 14 times 6 is going to be 60, plus 24, which is 84. 84 minus 3 is 81, so that's plus 81 equals to 0. And here we can use factorization, so we write out all the possible factors of 81, but it was easy, it's going to be just 9 and 9, so x plus 9, x plus 9, and we solved it. It is x equals to minus 9, because both of those will give us x equals plus 9 equals 0, so solving that will give us minus 9 twice, which means that this is a repeated root of minus 9. And therefore we finished our quadratics topic of the discriminant, and you can exercise this on 2G.